According to the National Electrical Code, specifically Article 700.12a, emergency systems must be electrically separate from normal systems unless the code explicitly permits an exception. Article 700.12c does allow the use of a single feeder for both normal and emergency lighting, but only if it meets specific conditions. These conditions are: firstly, the feeder must have a minimum of 3 current carrying conductors plus 1 grounding conductor. Secondly, the feeder must be adequately sized to handle the combined load of both the normal and emergency lighting systems. Thirdly, it must be protected by a circuit breaker or fuse that is rated appropriately for the combined load of the normal and emergency lighting. UL 924, which is the standard for emergency lighting and power equipment, also addresses the separation of normal and emergency circuits. Section 32.63 of UL 924 clearly states that emergency lighting circuits are not permitted to share branch circuits with normal lighting circuits. Given both the NEC and UL guidelines, the use of one set of conductors on a 2-circuit track for both normal and emergency lighting is not allowed. Each lighting system, normal and emergency, requires its own distinct and separate circuit. This ensures that the emergency lighting functions reliably when needed, without being affected by any issues in the normal lighting circuit. Maintaining this separation is crucial for safety and code compliance. This separation also prevents a fault in the normal lighting circuit from disabling the emergency lighting, and vice versa. Understanding these requirements is essential for anyone involved in electrical design and installation, especially when dealing with emergency systems. The NEC and UL standards provide a framework for ensuring safety and reliability in electrical systems, and compliance with these standards is not only a legal requirement but also a critical aspect of responsible electrical work. When designing or installing lighting systems, it is always important to consult the latest editions of the NEC and relevant UL standards to ensure that the work meets all applicable requirements. Also, local electrical codes can vary, so checking with the local authority is recommended. Considering the specific scenario involving a 2-circuit track, it is imperative to provide dedicated wiring for the emergency lighting to adhere to both NEC and UL regulations. A 2-circuit track typically implies 2 separate hot wires and corresponding neutral wires within a shared physical track. However, using one hot and neutral pair for normal lighting and the other for emergency lighting does not meet the requirement for complete electrical separation as mandated by the codes, especially UL 924's prohibition against sharing branch circuits. To properly implement emergency lighting within a track lighting system, one needs to ensure complete segregation of the normal and emergency circuits. This might involve using a track system specifically designed to accommodate separated circuits or employing alternative emergency lighting solutions that do not rely on shared infrastructure with normal lighting circuits. Furthermore, the transfer switch mechanism that activates the emergency lighting should be independent of the normal lighting circuit. This switch should automatically switch over to an emergency power source such as a generator or battery backup upon failure of the normal power supply. The sizing of conductors for emergency circuits must account for the total load of the emergency lighting and any other emergency equipment connected to the circuit. The overcurrent protection devices, like circuit breakers or fuses, must also be appropriately sized to protect the conductors and equipment from overloads and short circuits. Regular testing and maintenance of the emergency lighting system are crucial to ensure its proper functioning. This includes periodic testing of the automatic transfer switch, battery backup, and lighting fixtures. Documentation of these tests and maintenance activities is also important for compliance and safety purposes. In summary, while track lighting offers flexibility in lighting design, the integration of emergency lighting requires careful consideration to adhere to both NEC and UL requirements. The key is to maintain complete electrical separation between normal and emergency circuits, ensuring the reliable operation of emergency lighting when it is needed most. This may necessitate using separate track systems or alternative emergency lighting solutions to meet code requirements. When working with electrical systems, always consult with a qualified electrician or electrical engineer to ensure that the work is performed safely and in compliance with all applicable codes and standards. Incorrect wiring or improper installation can create safety hazards and lead to code violations. Remember that electrical codes and standards are constantly evolving, so staying up to date with the latest requirements is essential for anyone working in the electrical field. Regular training and continuing education can help ensure that electricians and electrical engineers have the knowledge and skills necessary to perform their work safely and effectively. In addition to the NEC and UL standards, there may be other applicable codes and standards that apply to emergency lighting systems depending on the specific application and location. For example, local building codes may have additional requirements for emergency lighting in certain types of buildings. It is important to research and comply with all applicable codes and standards to ensure that the emergency lighting system is properly designed, installed, and maintained. Proper planning and execution are paramount when integrating emergency lighting into any electrical system.